founder of Human Octopus. He is currently building two more startups, which is apart from Human Octopus, and also researching in the field of computational biology. And he's going to speak about the unfair advantages of PaLM LLM, Versatility for developers and businesses. There you go.
Yes, thank you for the introduction. So, once again, I'm Roshan. I've been building multiple startups. I've failed in many, but I've also succeeded in some. Currently, I'm building two more startups called Veloit AI and Unveiling. So, today, the whole story of this talk. Just a second.
There's a small announcement. I call upon Abhishek to make the announcement.
And so, how many of you have heard GD's Google Developer Expert? Do you know what this program is? Okay, so we have few experts at the community launch. So if anyone is interested to know more about Google Developer Expert program, so you can go to community launch. So it's from 12 to 12:30. So you can interact with them and get to know more, how to kind of get started or what exactly this program is. And second announcement is from ResumeX. So people who have kind of uploaded their resumes, they can collect their avatars and can get a chance to win Amazon Eco. So, sorry to interrupt. So, over to you.
Thank you. So I suggest GD is a perfect opportunity to engage with a lot of Google developers. So, getting back to this talk, as I introduce myself, I'm Roshan. I've been building multiple startups and failed in some, but I'm also building some more. And today we'll be looking about one of the most important large language models, which is PaLM 2. This talk is my journey on how I figured out PaLM 2, how we built it, how we use PaLM 2 to solve certain peculiar issues when it comes to Veloit AI. So to give a tiny background about Veloit AI, Veloit AI is a platform where no-coders, developers, businesses, small-scale startups can build machine learning models just by uploading their data set, clicking a bunch of buttons, and then you'll end up with an API website that you can directly integrate it into your tech stack. So one important peculiar problem that we met with Veloit AI is the people who are interested and signed up to a platform had peculiar project names. The project names or the machine learning models that they were building didn't have any definite meanings, right? So on brainstorming this, we figured out that the most probable cause for this unexpected behavior from our users is because they didn't know what to build. Most of the project names were literally like testing 123, ABC, 123, QWERTY, XYZ. So it didn't have any definite meanings. So on brainstorming on this specific problem, we figured out that people were interested in our platform, but the problem was they didn't know what to build, they didn't know how to use their data to make meaningful data-driven decisions. So that's where I went on a lookout to find the large language model that would understand the person's requirements as well as properly provide them a use case that they can use to do data-driven decision making. So today we'll be checking about PaLM 2, how it can aid businesses and developers build amazing large language model solutions. This talk is going to be about its predecessor PaLM and then how PaLM 2 was built, what PaLM 2 is capable of, and we'll be seeing some code snippets on how to integrate PaLM 2. As a keynote speaker, gave us an amazing introduction about large language models and generative AI. I'll be skipping some certain parts of this. You can avail the slides from the organizers to have a broader view of the same. So the first one, PaLM 1. PaLM 1 was introduced back in 2022. It was state-of-the-art, amazing model capable of explaining jokes and translation, physics QA, language understanding, and etc. So it uses pathways architecture. It's a novel architecture where only certain part of the neural nets were fired on. This reduces the inference time and also fewer the costs. So the next big introduction was PaLM 2. Google felt PaLM was not up to the mark. So what they basically did is they upgraded PaLM 2, they integrated much more things, But usually upgrade comes with larger size, bigger stuff, right? But this time, Palm 2 was in fact smaller. So that's what this Horlicks box is basically. So instead of bigger model, Palm 2's parameters were actually less. Palm is said to have 540 billion parameters, but Palm 2 is said to have only 340 billion parameters. So Palm 2 once again is a smaller parameter model, but in terms of its advancement, it ate Palm literally by a factor of 20% in each use cases. It provides high accuracy, faster than before inference, much more reduced cost, and it uses certain technologies such as pathways, compute optimal scaling, and improved data sets to provide such amazing benefits. So this is basically how Palm 2 was built. It follows the same old 4 processes of how any model is being built, starting from data preparation till model architecture. And one unique important part is model training and model evaluation. It's an iterative process where a specific human is also involved. This process is called reinforcement learning with human feedback, where a domain expert is made to evaluate the output of the model and then force the model to be better. So reinforcement learning involves generating a reward as well as giving it a penalty whenever it generates not so up to the mark content, right? So this iterative process made Palm 2 much more better than Palm 1. So this process yielded us 4 important models, which is Gecko, Otter, and Bison. Gecko is the smallest model of all. It's so amazing that it can run on a flagship. It is capable of generating 18 words per second. Yes, it can actually run on our mobiles. And Otter is the model that strikes a balance between performance and efficiency. It is also capable of whatever Gecko is capable of, and also additionally does summarization. Bison is the coolest guy in the room. This is what we'll be using, and this is what Google has exposed us to use as well. It is an incredibly powerful model which is capable of doing everything, including summarization, physics QA, joke explanation, even though the joke is, maybe dad jokes or something. But it cracked most of the state of the art. In fact, all of the state of the art assessments, right? And then we have Unicorn, the most biggest and most powerful model of all. Apparently, we don't have access to it. Some say Bard uses Unicorn. So coming to the new introductions in Palm 2, well, Pathways was already introduced, but I thought it would be nice to include, to talk something about Pathways. Pathways is a novel architecture which involves only using certain part of the neural net. It's not going to turn up the whole neural net to generate a prediction or something. Instead, these paths are specifically fine-tuned or trained for each and individual tasks. This is cleverly done by sharing certain parameters across each task. By sharing these parameters, we're able to fine-tune each parameters for multiple tasks. If you're taking translation, if you're translating English to Tamil or German back to English, certain parameters were shared across each task. This enabled the model to capture nuances between each task. This eventually made that model generate a deeper understanding about each tasks and was able to achieve state-of-the-art performance. In fact, go beyond state-of-the-art performance in multiple tasks. Compute optimal scaling. The conventional process of building a machine learning model, or what we usually think is, when we build an algorithm, when we use a model, when we provide it more data sets, it means the accuracy is going to be more, right? But what people at Google DeepMind and Google Brain and Google DeepMind thought was pretty different. They saw that the model as well as the data set should be scaled in a 1:1 ratio, right? So by using optimal data set for the optimal model architecture, they were able to make the model smaller as well as quick and inference. So improved data set, as usual, it used a huge amounts of data. In fact, it's so awesome to know that the language distribution in Palm 2's data set consisted of 0.2% of Tamil and other numerous languages, right? A significant amount of non-English data were used. By using multiple languages, and this improved data mixture allow the model to grasp more cultural data or cultural experiences by learning on them. So these new additions and the amazing improvements and novel architecture gave rise to some amazing results. Of course, there are a lot of state-of-the-art assessments that we could do, but then I personally wanted to check it, right? So, I mean, there might be a biased comment here, but then the point is we could see the difference between what Google Translate does and what PaLM is capable of. So, the specific difference is நான் ஒரு JavaScript வெறுப்பன், that's totally wrong, and then the other one நான் JavaScript-ஐ வெறுக்கிறேன். So there is a clear difference between the translation, right? Bart captured it perfectly while Google Translate was lagging behind. The next most amazing part was reasoning. This is the most interesting part as well. So I'm also a master's student currently pursuing my data science. We have a subject called CDC. Apparently, I still don't know what it stands for. I just finished the semester. But the point here is they give us a lot of reasoning problems. So this is one such problem where a guy called Silesh has to go around here and there. Apparently, we humans rely on spatial quotient to figure out where we stand in the space. Models cannot infer they cannot infer space, right? They are basically an autoregressive model that's going to map between the input and output, flip a million of matrices, multiply them, do a bunch of fancy calculation, and then come at a solution. But what I saw with PaLM here was incredibly amazing. It was able to figure out the directions in which Silesh moved, and then finally provided me where he stands currently. This is the fact why I specifically chose PaLM over other large language models. It was not an arbitrary decision. For our use case, we expected our large language model to act intelligent. I was really emphasizing on the intelligence in artificial intelligence. Most of the models that we have today are just fancy approximator functions rather than some LLMs that display genuine intelligence or maybe can go beyond the box in generating content for us. And that's exactly what I meant with PaLM 2. The next one is coding, obviously. Send an output, give a prompt, get the code, copy paste it, right? So this process right here is not just about coding. I gave my Bart or gave PaLM 2 a prompt about a Python architecture of a neural net. I asked it to convert it, a TensorFlow model, and then asked it to convert it into a PyTorch model with comments in Tamil, right? So it's two sets of translations. It's going to translate Tamil as well as it's going to translate, it's going to create Tamil comments as well as translate from TensorFlow to PyTorch. The amazing part was, guys, it works. When I copy paste it, the code simply works. So this brings me to the next part, the most exciting part. What developers, we developers love something, right? What do we love the most? Free stuffs. So when it comes to large language models, its capabilities are vast. We can build amazing products. There are companies that were born just basically months old that are generating $20,000 to $40,000 per month in their monthly recurring revenue. And providing such technologies for free is incredible. Of course, it helps us pass in our exams too, but then an amazing technology which has immense potential, vast number of use cases, has the potential to, we can integrate it in our applications for free. Of course, there is a tire, I guess it's 90 requests per minute. But what we developers love most is more free stuff, right? That's where embedding comes in. Embedding literally is an amazing technology. It's such a versatile part of large language models that helps us go beyond just generating stuff from a small input. PaLM 2 currently, this free tire model currently accepts 8,000 input tokens and is capable of generating 1,024 output tokens. But with embeddings, we can create large language models or use our large language models to address bigger issues where the data incrementally increases. So to the most exciting part, we'll be seeing some code snippets. This is basically the fundamental backend of most of the startups in this year. This is an API request to PaLM 2 API. You can get your API, so you can see the very big URL out there. The model that we'll be using is text bison to generate text, and you can get your free key from MakerSuite. So these are some bunch of parameters that our keynote speaker already explained us about. But I specifically wanted to emphasize on safety settings. Safety settings is providing a model or allowing a model to generate something and then giving it a specific threshold. When it comes to Veloit AI, the problem was there are certain sensitive topics in the field of medicine, and there are certain users from the field of medicine who are using Veloit AI to take data-driven decisions with their medical data. Sometimes PaLM may not be comfortable generating content with respect to medicine or any other specific part, but then by using safety settings, providing it a threshold, we're able to generate appropriate answers or appropriate solutions even for some of the most sensitive use cases. So these are some of the harm categories that we have. By providing thresholds, we can enable or provide PaLM an alternative or better way to generate appropriate content. These are some of the examples. The first one is grammar extraction. I know I'm doing masters, but I still don't know what verbs and adjectives are. But the basic concept in grammar extraction is we import our Python package. This example is Python package. I'm pretty sure why there is no JavaScript example here, I guess. So we have some default parameters. We define our model. We provide it our temperature. We provide candidate count. Candidate count is the number of drafts we want our model to generate. And then we have top P, top K, and maximum output tokens. Right? By providing such default settings and configuring our API keys by calling genai.config, where we imported this package from Google Generative AI package. Right? We were able to generate text using the following function, and then simply print the function. Right? The next part is sentiment analysis. Well, 5 years before, sentiment analysis in the field of NLP was state of the art. It was a huge use case. Only seasoned machine learning engineers were able to do it. But almost all NLP tasks in our daily lives, such as classification, sentiment analysis, and certain extraction processes, tokenizing, all that is simply converted in this one single API, which means we are able to solve widely most of the use cases in the field of natural language processing with just one API call. So this is a specific example on that. We just provide a sentence, and then we provide a sentiment, and then we ask our large language model to classify what type of sentiment our input is. Using the same generate function, by calling the configure function to configure API keys, we're able to accomplish this easily. The most important part here is extracting data to JSON. Well, I can't emphasize the fact how important this is. Extracting names or any data to definite form, the form of JSON, is literally amazing. I mean, you need to figure out the discussion between a front-end engineer, back-end engineer, to and fro files and figuring out the appropriate JSON format. Here, the model clearly gives you in JSON format that you can easily parse it. So here I've been using the eval function. If you see in the last line, you see the eval function. Eval function basically parses the string from JSON to converts it into a real JSON object that you can simply use it the same way how you use a dictionary, right? This is one of the most important part why I use Veloit AI. Why I use PaLM 2 in our startup. The next part is chat with PaLM 2. In the prior use case, we saw text bison is being used, but now we'll be using another model. This is basically the fine-tuned version of text bison. This is fine-tuned to interact with us in a humanly manner, ask back questions, as well as engage in a conversation. So it goes as this, as the keynote speaker spoke about few shot learning, one shot, zero shot. This is an example of few shot learning. Few shot implementation. I just made a while loop where we append our inputs and then we use GenAI.chat with the default parameters, except one change. We'll be using chat-bison colon 001 instead of text bison. So the same default settings, we pass our context, we pass our example and sample messages, and then we can engage in a chat. This is a simple example of how we can build simple chatbots, right? So in this example, we gave a prompt of, to engage with us just like a snowman, and this is what we exactly had. I asked the snowman to come down to Chennai. I said it's already cold, but then apparently it's not here, guys. The most important part is embeddings. Embeddings is an incredibly fun topic, yet it's pretty complex. This is the basics of retrieval augmented generation, where we pose a question to our large language model, which is amazing at providing us answer from a context. But then if the context is just incredibly big, we can't squeeze the context into our large language model, right? So this is where RAG comes in. What RAG essentially does is, it's going to extract data from our vector databases such as ChromaDB, VectorDB, or we can just simply store it in our local systems and use some fancy functions called cosine similarity or dot np dot dot to calculate relatedness of our input as well as the number of indexes, the number of entries in our indexes to get the appropriate context that can answer the question, and then feed that context back into our prompt with that question, and we are now able to specifically provide the model the part from which you need to answer questions and then the question itself. Now our model that can't, that has a limited context window can answer from a huge database. So this is the basics of vectors and operations. Basically, whatever context or whatever data we have, this is basically converted into numbers, right? I suggest you all to read Jay Alma's work on Versatility. This is an amazing blog. I've attached the link below. It's a must read if you are getting into Versatility embeddings and stuff. So basically, whenever we represent an object such as G or person one or king, queen, boy, man, whatever it is, our words are basically converted into numbers or embeddings, as said by the keynote speaker. It's basically embedding vectors, and these vectors, we can engage with these vectors just as the way we engage with vectors in mathematics. We can add them, multiply them, find relations between them. When we plot them in our vector space, we'll be able to find where they stand next to each other, and by these comparisons, we are able to appropriately find the specific context that is capable of answering our questions. So this is a tiny implementation of how you can use vectors. We'll be using generated embeddings from the same package, and we'll pass our model as well as the sample text that we want to convert into our embeddings. And this is what the output is basically. The output is basically a huge array of numbers. I guess it's 768 in length, that captures meaning from our given data, right? It extracts meanings. If we go to the previous slide, we are able to see that queen has specific color encoded, woman is color encoded into a different context, and then girl, boy, all have different color codes, right? So this basically corresponds to different numbers that can be, different numbers of size, of varying size. So this is another example where we create a database. Each text is converted into a database, and then we can use PaLM to generate embeddings, fill that database, and then use np dot dot to find the most appropriate element in our database to answer our questions. So once we find the appropriate answer for our query, we are able to find the appropriate relevant passage through which we can do some fancy prompt engineering, and then we can derive an answer from the normal generate text function. So these are some of the use cases. MedPalm, SecPalm for security. This is basically a fine-tuned model. A Palm Telegram bot. You can check out the GitHub URL here. And then AI Study Assistant, Aroma Journey app are some of the amazing use cases by developers around the world who have built amazing applications using Palm AI. Thank you guys.